Okay, when we're talking about acids, acid and base reactions, we have a lot of definitions, bunch that you should know. And then the first one is write the names and formulas of all the strong acids and strong bases. I refuse to do that and have you watch me for 3 minutes writing this out. It's easy. You should know the formulas, you should know the names. On my exams, that's what you'd be asked. Just give them all. Definitely, several of these are all halide acids, or halogen acids. Lithium, sodium, potassium are all from group 1A. Calcium, strontium, barium, group 2A. So there's a lot of little trends, but basically we use so many of these so often that you shouldn't have too much trouble. Let's go on to a problem here. Which of the following are strong acids and bases, and which are... Okay, so we're just sorting them out. Strong acids, strong bases, weak bases. Well, you just saw the 6 strong acids, 6 strong bases. If we come up with an acid and it's not one of those 6, it's weak. Doesn't mean that it's harmless and that you should drink it down. It just means that it doesn't dissociate 100% like those ones that we just saw. So, we see copper 2 hydroxide. Hydroxide indicates that it's a base. Is it one of these 6? No. So this is a weak base. HNO3, that's nitric acid. That's one of the strong acids, so SA, strong acid. H2SO3, well, H2SO4 is sulfuric acid. H2SO3 is sulfurous acid, so this is a weak acid. If it's not one of the 6, then it's weak. Very simple. So no matter what crazy acid you're given, and how do we know it's an acid? There's a hydrogen out front. We're told that it's a problem about weak acids, or about acids and bases, so it's one or the other. So if there's a hydrogen out front, we assume that it's an acid. NH3, that's ammonia. We know that that's a weak base, or you should know. That's one of the most important weak bases that we have. We use it quite a bit throughout the text. HC2H3O2, you should know that that's acetic acid. We know that name. That H means it's an acid. It's not one of the 6, so weak acid. So if you know the 6 acids, strong acids and strong bases, you're all set. HClO, HCl is a strong acid. HClO4 is a strong acid. HClO is a weak acid, not one of the 6. LiOH, that's one of the strong bases. So there we go. So if you know the 6 strong acids, 6 strong bases by name and formula, then these kinds of problems will be very simple. Okay, complete and balance each of the following neutralization reactions and write the net ionic equation. When you see neutralization reaction, you know that you're dealing with an acid and base. You'll be producing a salt and quite possibly water. But not always. So you should know that that's what you're dealing with. HBr, that's hydrobromic acid. Calcium hydroxide, both are aqueous. Calcium bromide, if you look at the halogens, you see that calcium bromide is not one of the exceptions, so it's aqueous. And then we also get 2H2O, and this is liquid. So we get a salt that's made up of the ions from the acid and base, and then we get water in this case, which is liquid, so it doesn't break up into ions to any extent, and it remains intact when we start dividing up the molecular equation into the complete ionic equation. So I just want to make sure everything's balanced here. Oh, we need a 2 here. Now, so we break it up into ions, 2H plus, 2Br minus, calcium ion, and the aqueous phase I'll put in there. I'm going to write it pretty fast. It might be tricky to see, but if you see an ion with a phase, it has to be aqueous. For us, it has to be aqueous. Try to write it so you can read it. Then we got our 2 water that are liquid. They're part of the solution now, so they're liquid. We have the bromides are spectator ions, the calcium are spectator ions. So when you have a strong acid and a strong base, the overall, or the net ionic equation, the CIE, the NIE, all that's happened is that the H plus from the acid, the OH minus from the base react together to form water. That's the overriding So when you so when you put a strong acid and strong base together in the lab, and you see all this fuming and all this bubbling that can occur from the heat that's given off. It's really, this is all that's happening. These guys are coming back and forming water. Okay, now I should say, this was a strong acid, strong base. I'm going to make, I have 3 more here to count for the different kinds of reactions that we can see with acids and bases. Now this is a weak acid and a strong base. Now for those who, they get the first one done, they say, okay, that's right, it just makes water, H plus OH minus produces H2O, and they're done, and they don't pursue it any further. Well, this is why I'm doing out these other 3, because there are some differences. So a weak acid does not break up into ions to any extent. So even though it's aqueous, and this is aqueous, for KCN and H2O, and so see, it's making H plus and OH minus here, produce water, but this doesn't break up into ions, so we leave it alone. We leave it as is. It's aqueous, but it doesn't break up into ions. This is an ionic compound. See, HCN is a molecular compound. It's an acid, and it does break up into H plus slightly, but since it's the vast majority of it stays intact, we leave it intact. So it's like ammonia. It's a molecular compound that we leave intact. In this case, it's a weak acid rather than a weak base. This KOH is an ionic compound. It's a base, but it's made up of ions. Those break up. K plus, Cn minus, and H2O as water. Says, well, it still looks about the same. Well, take a look here at spectator ions. This HCN, because it doesn't break up into ions, that's the difference. So the full molecule reacts with OH minus to produce Cn minus and water. So we see that we have the complete ionic equation where we leave the HCN alone and the water alone. And the net ionic equation is slightly more complicated than the strong acid, strong base one, which was just H plus OH produces water. Because this remains intact, we have to carry it through. And so it's a little trickier. Let's look at a strong acid and a weak base. Well, the H plus attaches to the ammonia to produce ammonium, and this would be ammonium sulfate. And I say, well, wow, that's kind of a leap. It's not that much of a leap as long as you, when we deal with ammonia and it reacts with an acid, it becomes ammonium ion. That's simply what it becomes. So if you have ammonia and it's reacting with any acid, it becomes NH4 plus. So, but let's break it up into ions and so that you can see exactly what happened if this is the first time you're seeing this. So we have 2H plus. That's a strong acid, so it breaks up into its ions completely. We have 2 ammonia. That's a molecular compound. It's a base, but it remains intact. We have 2 ammonium ions. Breaks up, and the sulfate, because ammonium is always soluble. Any compound that contains ammonium is soluble. And we have sulfate. So the sulfates, spectator ions, so we have 2H plus 2 ammonia produce ammonium ion. No water in this case. So this is why we always say we produce a salt, ammonium sulfate in this case, and sometimes water. Almost always, but when you have this example here, you can see there's no OH minus as part of the ammonia, so there's no water that's going to be produced. So when ammonia is involved, you don't get water as one of your products. And so this is our net ionic equation. And then the last one is a weak acid, weak base. So we did strong and strong, a strong acid, strong base, weak acid, strong base, strong acid, weak base, and now we're doing both weak. So in this case, this is aqueous, produces ammonium ion. When you ever have ammonia with an acid, it will produce ammonium ion, and then so ammonium acetate. And so this remains intact. So does the ammonia. Oops. Then we have the ammonium ion that breaks up, and the acetate ion that breaks up. Now, we look at it, is there anything that can cancel any spectator ions? Nope. So unfortunately, I'm sorry about this, having to bring it down here. That's it. So the complete ionic equation is also the net ionic equation. So all of these four combinations of weak and strong acids and bases come up with a different form. So you should know them all, and never assume that you by looking at one example that you have it all figured out. And in these lectures, when there are several different kinds of problems, I do them all. So, or an example of each one anyway.